Hello, guys. This is now our fourth subject here in our review for the Chemist Licensure exam. This crash course video will be our first lecture here in Organic Chem. Hopefully, guys, may naaalala pa kayo sa undergrad ninyo sa mga lessons sa organic. Okay, so what we will do here, of course, is we will recall majority of the topics that you already know from your undergrad. Okay, if you had maybe two or three subjects, guys, sa organic before, lahat yon. Okay, dapat majority guys ng topics from those subjects, dapat maaalala ninyo and you will be using them here in our review for organic for the chem boards. Okay, so let's begin, guys. So let me tell you what to expect for the course of our organic chem review. So we have 10 practice tests. So ayan guys, some topics. Each practice test is worth 10 items. So you will see na familiar, di ba? Familiar yung mga topics dapat na ito sa inyo. And, ma'am, bakit may asterisk po yung PT 8 and 9? Because guys, this organic chem topics are related to the biochem topics which I will also handle. So, yung biochem, guys, yung orange dito. So, PT1 in biochem, I will also teach you that. That's the chapter on carbohydrates. It's actually a continuation of the topic here in organic chem under aldehydes and ketones. And then naman, guys, yung PT2 ng biochem, which is lipids, is actually also on a continuation for PT9 ng carboxylic acids and derivatives. Okay? So guys, hopefully together with your readings dito sa manual natin tsaka sa mga books na sasabihin ko sa inyo, we will be able to review organic chem before you take the board exams. Dapat maging prepared kayo, guys. Kahit sabihin nyo na hindi ito kasing mathematical ng in-org, analytical, or phy-chem, madami kasi guys, marami ding dapat aralin here in organic chem, even in biochem. So you also have to spend enough time reviewing these topics. Okay? So let me share with you guys naman yung mga books na nire-recommend ko na gawin nyo ding references. Basahin nyo rin yung mga chapters sa books na to. So you will be seeing a lot from McMurray's book and from Smith's book. Okay, so actually more on Smith yung mga images natin. At saka yung mga makikita nyo guys sa manuals natin, sa slides dito, more on Smith yung source or reference natin. Okay, so guys, I still encourage you to read our references before kayo mag-take ng mga practice tests and of course ng mga exams natin. Okay? One more thing, guys, na makakatulong sa atin in our review is the use of molecular models. Ayan. So here are actual pictures ng mga models, guys. And actually, dito sila. Katabi ko lang sila. So we will be using them later to help you visualize clearly yung mga molecules and of course yung mga properties nila. Now, sabi nga guys sa book ni Smith, most students in organic chem find that building models helps them visualize the shape of molecules. Mag-invest na raw sa set of models. So it's up to you guys. If you have such models, then you can use them. If you want to purchase, it's up to you. Yung color coding, guys, ito. Ito rin yung exact na color coding ng mga atoms sa models na ipapakita ko sa inyo. So black is for carbon, white for hydrogen, red for oxygen, blue for nitrogen. Although hindi tayo masyadong gagamit ng fluorine. Chlorine, yes. Green, bromine, yes. Maroon, orange siya dito. Sulfur, phosphorus, ayan. So this will be also the color coding scheme, guys, na makikita ninyo sa mga models that we will use here in our crash course. Okay, now let's move on to the first chapter. So guys, ito ay part ng PT1. PT1 has 3 parts. Ito guys ang first part, nature and scope of organic chem. Second part is structure and properties of organic compounds. And guys, yung third ay nomenclature. You'll find them here guys sa table of contents sa manual natin. So this will be your guide if you are already making progress. Kung nagpo-progress na kayo sa mga topics sa organic chem. Here in our first chapter, ito guys ang subtopics, history of organic chem, properties of carbon. So, very quick recall lang to guys, no? Ng history tsaka properties of carbon. So, most of the things naman na ituturo ko sa inyo here in the first few chapters ng organic chem review natin. I'm sure familiar pa kayo. Okay, so let's start with history of organic chem. So you'll find the info, guys, about history sa page 1 ng notes natin sa manual. So let me just give you guys important names. So first, Friedrich Wöhler. Remarkable, guys, kasi for the first time, an organic compound was synthesized from an inorganic source. So remarkable si Friedrich Wöhler because of the urea synthesis that he has performed. And then si Kekulé naman, guys, of course, carbon is tetravalent. Yan ang remarkable sa kanya. Van Hoff, remarkable sa kanya, carbon is tetrahedral. Of course, guys, Gen Chem pa lang, you already know J.N. Lewis because of the electron dot structures, or also known as Lewis structures, and Linus Pauling because of hybridization and resonance. So, you'll find them, guys, sa table na to. The first table that we have in our organic chem notes. And again, guys, let's emphasize yung synthesis ng urea from ammonium cyanate, which was performed by Friedrich Wöhler. Okay, next, properties of carbon. So we already know this, guys. Organic chem is the study of compounds containing carbon. The common features of organic compounds that can explain their vast occurrence are as follows. Carbon is tetravalent, forming 4 bonds with itself and other elements. Guys, other elements may be present. We call them heteroatoms. So heteroatoms are those atoms or elements that is not carbon or hydrogen. What are these? We have oxygen, we have nitrogen, sulfur, phosphorus, and of course the halogens. Carbon has the ability to form single, double, and triple bonds. Carbon atoms can bond with each other to form linear branch or cyclic chains. Organic molecules exhibit structural isomerism and stereoisomerism. So this is just a preview, guys, usually that you can read from books about organic chem and of course organic compounds. Now, guys, mag-recall lang tayo. How do we draw organic structures? Kailangan kasi, guys, pag susunod na kayo ng reactions, when you write mechanisms, when you predict products, of course, you have to recall, paano nga ba mag-draw ng organic structures? Is it like this? So usually, guys, ganito tayo, no? If we want to emphasize the atoms, or minsan naman, kung nagmamadali, pwede na, guys, ang condensed structure. And of course, for me, the easiest one is to use skeletal structures. Okay, so most of the time, you'll see me, guys, using skeletal structures. So I'm sure everyone familiar pa kayo, guys. Alam na alam niyo pa kung paano mag-represent ng mga organic molecules. Guys, in the next slide, meron tayong dalawang molecules na naka-skeletal structure. So we will determine, okay, through our first sample problem, if you know how to detect how many carbons, how many hydrogens given a particular structure. Ayan. So here's our first sample problem. Baka kala nyo, sa organic chem, walang sample problem. Meron din, guys, pero hindi nga lang mathematical yung nature. Okay? So give the molecular formula of the following molecules. Here's our first one. This compound is known as capsaicin, which is the spicy component of hot peppers. So, okay, so guys, magkusulat tayo, ha. So anong gagawin natin? You will count how many carbons are present, how many hydrogens. Ang madali kasi, guys, makita dito yung heteroatoms. So obviously there are 3 oxygens, so O3, tapos isang N, no, diba? So NO3, that will be the last part of your formula. However, we have to count how many carbons, how many hydrogens. So guys, game, ha? So let's start. This is already 1 carbon. This is actually, guys, CH3. Okay? And then, of course, benzene ring. So that's 6. So meron na tayong 7 carbons. This is 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is C18. Okay, how many hydrogens are present? Oh, guys, unahin natin itong nasa benzene ring, ha. As you all know, ang formula, guys, ng benzene, C6H6. There is 1 hydrogen for each carbon. However, may mga substitution na meron, guys, sa benzene natin. Substituted siya. So there are only 3 hydrogens left. So that's 1, 2, 3. And then 3, guys, yung hydrogen dito. So that's 6. OH, may hydrogen. That's 7, 8. Okay, ito na. So meron na tayong 8 ha. So ito guys, i-add nyo na lang to. So this is CH2. Kayo na guys mag-add. Tapos ito ay CH2 also. CH2. So I'm just writing guys ha, para sure na tatama kayo. And then ito may double bond pa na yan. Ito CH. Remember guys, neutral molecule to. So it follows the octet rule. CH3 naman to, substituent, and then CH3. Okay? So ano kaya ang answer for number of hydrogens? Okay, sirit na ha. Okay, the correct answer for capsaicin is C18H27NO3. Okay, so ayan, in-erase ko lang guys yung sulat ko. So that should be the correct count of carbons and hydrogens. And then our second compound is fexofenadine. This is a non-sedating antihistamine. Okay, so guys, let's count how many carbons are present. So we have 3 benzene rings here. So 6 times 3, that's 18. And then this one is 19. Okay, 19. Then you have 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. And then for hydrogens naman, guys, so you do the same, ha? Ginawa ko kanina. And then, of course, you have OH, OH, COH, and then N. Okay, the correct answer, guys. So you may pause the video if you're still counting and then check, guys, play again to check your answer. The correct answer, guys, for this compound, C32H39NO4. So this is just to check if you still know how to count carbons, hydrogens, and other atoms in a particular molecule, especially guys na naka-skeletal structure. Okay, so yan guys ang first sample problem natin. Now, we move on to chapter 2. Sabi sa inyo, madali lang yung chapter 1. Chapter 2 guys is about structure and properties of organic compounds. So we will talk about hybridization, bond properties, inductive and resonance effects. All right? So let's guys recall muna. Before tayo mag-move on sa topic ng hybridization, let's first recall the valence orbitals of carbon, carbon being 1s2, 2s2, 2p2. Okay? So these are the drawings. Okay? It's familiar, di ba? Kasi sa in-org may ganito rin kayo. So you have the s and the p orbitals. S is spherical, p orbitals naman guys, dumbbell shape, okay, yung kanilang hugis or geometry. And then, ayan na, so let me now show you the orbitals for the 2p. Okay, ito yung 2p orbitals guys na matatagpuan natin, okay, at magagamit natin later sa drawings natin for the atomic orbitals for carbon. So this 2px, 2py, 2pz, and of course the last one, wherein all 3 2p orbitals drawn on the same set of axes. So remember guys, in bonding, we usually deal with valence orbitals. As you will all remember from Gen Chem, valence electrons are the outermost electrons which are involved in chemical bonding. Okay, now let's define hybridization. It's the combination of 2 or more atomic orbitals to form the same number of hybrid orbitals, each having the same shape and energy. So here guys, an example of the combination of the atomic orbitals. So let's have here hydrogen. Diba guys, ang hydrogen, we write it as H2 because we know that hydrogen is diatomic. So the question in your mind, how does hydrogen atoms combine and form the H2 molecule? So we have here the 1s orbital of hydrogen. So we all know it's spherical, and another 1s orbital of hydrogen. So dalawang hydrogen atoms, how will they bond with each other? The answer is the concept of hybridization, wherein these 2 orbitals will combine. They will overlap. Okay, so that's another word that you will use here, overlap. So paano mag-overlap yan? Dalawang spherical, head-on overlap ng dalawang orbitals na yan, we form this bond. So guys, recall lang, ang tawag natin sa bond na to, which is the result of the head-on overlapping of the atomic orbitals, we call it a sigma bond. O, diba? Symmetrical, guys, ang sigma bond natin. Cylindrically symmetrical. Okay, so that's what we call a sigma bond. Now, apply natin, guys, sa organic compounds. Okay, syempre, let's look at the atomic orbitals of carbon. So 2s having a lower energy, nasa baba siya, and of course the 3 2p orbitals. So this is how we draw the orbital diagram, diba, of the electrons, guys, sa carbon, ng valence electron, sorry, sa carbon. So, di ba nga 1s2, 2s2, 2p2. So, we follow Affbaugh's principle, Hund's rule. Ito, guys, ang ground state. However, guys, ang tanong kasi natin, how does carbon form bonds with hydrogen, with carbon, with other atoms, and organic compounds? Ang sagot nga, hybridization. Paano? Ito, guys, ang ma-form. So when these atomic orbitals combine, yung 2s tsaka yung 2p orbitals, they will form one type, okay, one type ng hybridization pattern na pwede nilang i-form or i-bow-in ay ang sp3. If all 3p orbitals will combine with the s orbital, they're gonna form sp3 hybrid orbitals. Paano nangyari yon? Actually, guys, meron tayong mathematical equations. No? May mathematical version to eh. However, we will not deal with that. Ito, qualitative lang muna, guys, tayo dito sa hybridization dito sa organic chem. So, isang S, tatlong P, meron kang apat na sp3 orbitals. Again, ayan ang nakalagay, having the same shape. Ma'am, wala pang drawing. I'll show the drawing later. And obvious naman, guys, same ang kanilang energy. So, ito ang appearance ng orbitals nila. Ito yung mga shapes rather ng orbitals nila, S at saka P. So when they all combine, they will form 4 sp3 hybrid orbitals. Now in books, you don't usually see, guys, tong maliit na lobe. Okay, what you usually see is just the bigger lobe. So to avoid confusion, hindi na, guys, pinapakita yung lower lobe. So ito, guys, meron tayong hybrid orbitals na may larger lobe, no, it means that this will be more efficient sa pag-overlap with other hybrid orbitals later. Okay? So this is, guys, this is what we use to explain bonding in carbon. Okay, bonding in carbon and atoms present sa organic compounds. We use the concept of hybridization. So let's have our first example. Meron ako molecule dito. Ayan. O, diba? So, ayan, guys. This is methane. So, ang aaralin natin sa slide na to, paano ba na-form yung bonds ng carbon with hydrogen? A very easy example, guys. So, of course, yung carbon-hydrogen na yan, resulta yan, guys, ng sigma. Okay, di ba kanina, head-on overlap ng sp3 hybrid orbital ng carbon at saka ng 1s orbital ng hydrogen. So it's very simple. It's just the overlap, the head-on overlap of carbon sp3 and H1s orbital. Okay, so again, guys, sigma bond. Guys, one more thing about sp3 hybridization is its geometry. So we have here 4 bonds, diba? We have 4 sigma bonds created from carbon sp3 and hydrogen 1s surrounding carbon. And you will notice that they are arranged in a particular manner. Yung manner, guys, na maximize yung space around the central atom. Of course, these bonds, no, they contain electrons. We don't want the election pairs to be close to one another because we want to prevent electron pair repulsion. I hope you still remember VSEPR from your in-org, diba? So guys, no arrangement na to, we call this tetrahedral. Okay, because if you draw sides here, this will resemble the geometry of a tetrahedron. And of course, guys, another thing is the bond angle. Hindi na bago sa inyo yung bond angle, di ba? Bond angle, ang ating tetrahedral bond angle ay 109.5 degrees. So, ayan, guys, ang sp3 hybridization. Okay? In our next slide, sp3 pa rin, guys, pero mag-a-add tayo ng another carbon. Okay, ayan. O, diba? So, parang kawig din nung kanina, exactly. This, guys, is ethane. The second in line sa alkane family. Okay, so this is ethane, and we will also identify yung bonds present dito. So of course, sigma bonds din guys. However, diba? So this is new. Kanina wala tayong carbon-carbon bond. So again, for the carbon-hydrogen bonds is the overlap between carbon sp3 and hydrogen 1s. However, here's our question. Ma'am, paano po na-form yung carbon-carbon bond? It's formed from the sigma bond, again, from the head-on overlap of two sp3 sp3 hybrid orbitals. Okay, so yun yung bumuo sa sigma bond, guys, between the two carbon atoms. And as you will see, guys, it constitutes the single bond here, the carbon-carbon single bond. All right, so ito guys, ang ating dalawang example for sp3 hybridization. Okay, so let us put this down na. So we move on to the next pattern, which is called sp2. Ma'am, paano naging sp2? 1s and 2p orbitals lang guys yung nag-hybridize. So tatlo. There will be 3 sp2 hybrid orbitals that you will see here in our slide. And then, ma'am, paano po yung isang P? So, the other P, guys, yung pangatlong P, no, it will be unhybridized kasi hindi nga siya sumama or nakipag-join forces sa hybridization. This compound, yung ating next molecule, guys, this is ethylene. Common name, IUPAC name niya is ethene. It's an example of an alkene. Okay, first question. What orbitals were used to form the carbon-hydrogen bond? Of course, that's sigma, guys. So similar kanina. However, here, carbon is already sp2. So carbon sp2 and H1s, the overlap between them created the carbon-hydrogen bond. Next, so we see, guys, orange. So diba, same color. Orange kasi yun yung sigma bond between the two carbons. So pag sinabi natin sigma bond, that's the overlap between carbon sp2 with the note na yan ay head-on. Okay, head-on overlap kasi sigma bond yan. E ma'am, paano po yung other p orbital? The other p orbital, guys, has also its own overlap with the other p orbital sa kabilang carbon. This is how it will look like. This is called a pi bond, which results from the sideways or side-by-side overlap ng unhybridized p orbitals. O diba? So kung ang sigma head-on, pi bond sideways or sidewise, side-by-side na overlap. So together, guys, ayan, together, here are all the types of bonds in ethylene. So yung dalawang may color, guys, yung green tsaka purple dito, we can see that these two bonds constituted the carbon-carbon double bond. So guys, para mas makita nyo, guys, yung molecule, so mag-stop share lang ako ha. So you would see them. Ayan, masakita nyo kasi mas malaki. So this is our model for ethylene, okay? So you would see, guys, ito ang ating mga carbon-hydrogen bonds. So this was created because of the sp2 hybridization pattern. So again, H1s carbon sp2. So since alam nyo, guys, yung geometry kanina sa sp3, let's also determine the geometry here in sp2. So you could see, guys, na planar siya. 1, 2, 3. So the geometry for ethylene or for the geometry for sp2 hybridization is trigonal planar. Bond angle, guys, ay 120. So kung kanina 109.5 yung bond angle, ito naman, guys, ay 120 degrees. And ayan, nakita nyo rin, guys, yung ating parallel na p orbital. So they will form another type of bond, pi bond. This will be the result of the sideways or side-by-side overlap of the unhybridized p orbital. So again, guys, ito ang ethylene. Side-by-side, i-compare natin, guys, sa ethane. Okay, so ethane, sp3 hybridization, geometry around carbon is tetrahedral, bond angle 109.5 degrees. Here is ethylene hybridization pattern, sp2 geometry, trigonal planar, bond angle naman niya ay 120 degrees. Okay, so ayan, guys, ang ating mga models. Balik tayo for the next pattern. Our next pattern, guys, is SP. So isang S, isang P. And our example here is acetylene. Common name. Ito ay isang alkyne. ang name niya guys, IUPAC system is ethyne. So as you can see guys, hindi ko na inalis yung mga overlapping orbitals, 'di ba? Kasi same din naman. So yun nga lang, sp na guys yung pattern dito kasi isang S, isang P. So they form two hybrid orbitals, and then we will now determine yung mga types of bonds in acetylene. So ganun ulit, carbon hydrogen, CSP nga lang yung difference, and then H1S. Now here's our goal. Paano i-explain yung triple bond here in acetylene? So one bond there, okay, or one overlap there is due to the carbon sp-sp sigma bond. Another one, guys, is for the 2p2p you have seen a while ago. And the third one is the other pi bond. Kasi paano nagkaroon ng, bakit dalawa yung pi bond niya? Because, yung pi overlap niya, guys, paano nangyari yun? It's because, guys, dito, isang P na lang yung nag-hybridize. So, we are left with two unhybridized P orbitals on each carbon. Therefore, this can form two sets of pi bonds. So, ayan, o, diba? So, parallel. So, perpendicular actually, guys, yung dalawang p orbitals, yung dalawang pi bonds natin rather. So, iba nga lang yung colors ko dito, pink tsaka purple dito sa slide kasi natin blue tsaka purple. So, guys, here we have two pi bonds for acetylene. Okay. Stop share muna tayo para mas makita ninyo. So, ayan na. So, this is acetylene. Side by side, guys, natin sa ethylene. Ayan. sp2. Ang sp2, guys, natin kanina, trigonal planar, 120 degrees, or recall lang. This is sp. Ayan, so uunahan ko na guys yung slide. So makikita ninyo guys, ito ang ating carbon, ito ang ating hydrogen. So CsPH1S. And then ito yung sigma bond between the two carbons. So you would see guys the geometry being linear. So one angle guys, 180 degrees. And you also see yung perpendicular na pi bonds natin. Okay, so this is acetylene. So let's now go back guys sa slide natin. So ayan, you can see here yung version naman ng pi orbitals lang. Ng pi bonds lang. And then eto naman yung version, yung drawing na merong kasama na sigma bonds. So the overlap between sp-sp, sigma bond, overlap between the two between the two sets of p orbitals, yung dalawang pi bonds natin, those three overlaps, those three bonds, they constitute guys the triple bond, the carbon-carbon triple bond here in acetylene. So now you have seen the three types of hybridization, sp3, sp2, and sp. Ito guys yung nasa manual ninyo, show ko lang sa inyo ha. So you have there the summary. Doon nyo kailangan matakot na mag-drawing pa habang nanonood kasi you also have the same images in your review manual. Okay, here's our second sample problem. Determine the orbitals used to form each indicated bond. Okay, ito guys. So ang ating first molecule ay component. Isa sa components ng orange. Okay, guys, ito ang citric acid. So naka-arrow na. Okay, naka-arrow na guys yung mga kailangan natin na i-determine na type ng orbital. So let's have madali dyan. Yung alam natin, yung carbon-carbon lang muna. Ayan guys, ito carbon-carbon lang to. So obviously single bond yan. So yan guys, so sulat natin dito. That's carbon sp3, carbon sp3. Okay, so ayan, alam nyo yan. Okay, doon naman tayo sa may carbon pa. Tapos yung mga oxygen naman. Ito guys, obviously, this carbon is sp3, but the carbonyl carbon here is sp2. Okay, so carbon sp2. Paano naman yung carbonyl bond, yung carbon-oxygen double bond na yan? So carbon sp2, oxygen guys here is also sp2. Okay? Now, OH, o baka nagtataka kayo, ma'am, yung ganun din pala yung oxygen. Kasi guys, same row yung oxygen. Boron, carbon, nitrogen, oxygen, fluorine, di ba? So same row, same period sila. So yung kanilang valence election, yung valence election configuration nila guys, almost similar, only that mas lamang lang ng 1 electron ang oxygen. On the other hand naman guys, ito, As you can see, single bond, diba? So hydrogen there is 1s, of course. Yun na naman ang field na electron orbital ng hydrogen. And then oxygen there is sp3. Okay? And then we have here, itong tinutukoy guys, itong another bond, O carbon, sorry, oxygen carbon. So that is O, sp3, carbon, sp3. Okay, so I guess we're done with the bonds here in citric acid. So, isipin nyo na lang guys, sp3, sp2, sp. Diba? So, similar lang sa inaral natin kanina. The second compound here in our second sample problem is component naman guys, or compound from ginger. This is gingerone. Okay, so let's see guys, dito muna tayo. So, ito ang carbon-oxygen bond, yung tinuturo dyan. So, carbon, sp3, oxygen, sp3. Okay, next we have here carbon-carbon. So itong carbon guys, ito sure tayo sp3. To carbon within benzene ring, sure tayo guys sp2 yan. Because it is part of the double bond. What else? Ito, carbon sp3, sp3 din yan guys. So hindi ko nasusulat ha, madali lang. Ito ganun din. Carbon sp2. Okay, carbon sp2, and then of course hydrogen 1s. Okay, so very easy guys. These are the orbitals na nagamit, okay, to form each indicated bond. So you can also do it yourself. You can look for similar molecules or problems guys sa book natin. Okay, next. The next thing guys na related sa hybridization is of course bond length and bond strength. In your manual guys on page 3, ayan, may mga values pa ako nilagay. This is from McMurray actually. So we have here values for the bond length, bond strength. However, in this slide kasi, pattern lang yung nilagay ko to avoid confusion. Oh, you have the values naman here sa manual. So the single bond is our longest bond yet the weakest bond. Triple, shortest, strongest, SS. Okay, triple, shortest, strongest. So we can see that bond length and bond strength are inversely proportional. Okay, so tandaan ha, shortest, strongest ang triple bond. And I also mentioned guys here sa last paragraph on page 3 is that each sp3 orbital of carbon in ethane, yung ating example kanina, has 25% S character. Okay, ma'am, paano po naging 25% S character? Kasi guys, sp3, diba? So there are four orbitals there, tatlong P, isang S. So yung isang S over sa apat, obviously 1/4 or 25% S. Sulat natin. So guys, for ethane, so let's just recall no yung ating lesson kanina. So sp3 hybridized yan. So let's compute for the percent S character. So S isa and then tatlong P and then so over 4 no, isa lang yung S. So ibig sabihin guys 1/4 or 25% S character ito. Okay, so ma'am, ba't natin i-compute yan? Kasi guys, hindi lang yung carbon-carbon bond yung affected, also the carbon-hydrogen bond for each of the following examples here. Sige, sulat natin. So this is, yan, kasi connected kasi yung carbon ay sp2 hybridized, and then here as well, kasi yung carbon ay sp hybridized. So here guys, yan, sp2, ito naman ay 1/3, so 33%. And then last, sp hybridized, 50%. So how do we account yung properties ng carbon-hydrogen bond sa percent S character? We all know guys na ang S orbital closer to the nucleus. That's the reason why carbon bonds, even carbon-hydrogen bonds are shorter as the percent S character increases. Kasi baka kasi isipin nyo, ay yung carbon-carbon lang yung affected. No, also the carbon-hydrogen bond because it's adjacent guys, diba? Dun sa pinag-uusapan natin na hybridization. Diba? Yung hydrogen bonded dun sa carbon mismo. So they're also affected of the percent S character. So always remember guys, ang carbon-hydrogen bond wherein carbon is sp hybridized, highest yung percent S character niya among the three, it's also the shortest and the strongest. Later guys, pag nasa chapter na tayo ng alkynes, malalaman ninyo na magagamit itong natutunan nyo in this part kung bakit ganito yung reactivity or yung properties ng alkynes. Okay, so nirecall lang natin guys yung percent S character. Andito yan sa last paragraph sa page 3. Okay, so let's now have our third sample problem, xanthalpic acid. A fatty acid isolated from the seeds of the sandalwood tree. Ito guys, meron tayong picture sa right ng seeds ng sandalwood tree. It is an unusual fatty acid that contains a carbon-carbon triple bond. Rank the labeled bonds in order of increasing bond strength. So ito guys, ang structure ng xanthalpic acid. Ang gagawin guys natin, we will determine the bonds. Okay, the hybrid orbitals na ginamit for the following bonds. Magpapalitan ako guys ng color. Ayan. So let's have A. Ito ang ating bond A. So obviously guys, this is carbon sp3 at yung carbon na to, no, kasi ito yung nakaturong bond is sp2. For B naman guys, this is carbon sp2, carbon sp. For C naman, carbon sp and carbon sp3. So we will label the bonds A, B, C in order of increasing bond strength. So obviously guys, ang pinaka-weak, no, kasi increasing. So ang pinaka-weak dito guys ay yung bond A. Okay, ma'am, bakit? Well, it's a single bond. Okay, bond A is a single bond. Therefore, siya nga yung weakest natin. Ma'am, single bond din naman yung C. Okay, but wait, kasi itong isang carbon sp2, one carbon in bond C ay sp, higher percent S character. Okay? So para-pareho namang single bonds pala sila actually, no? So single lang A, single lang C, single lang B. Yun nga lang guys, yung carbons. Okay, different yung hybridization patterns ng mga carbons involved in the bonds. Okay? So ayan. So A is our weakest, followed by C. O ma'am, paano naging strong yung B is single bond din naman pala siya? However guys, look at the carbons. sp2 at sp naman kasi. Okay, so the correct answer here is A, C, B. Alright? So guys, kahit na pare-pareho silang single bonds you look at the hybridization pattern of the carbons because nagkakaroon guys ng effect. May malaking effect yung percent S character. Remember, S orbitals are closer to the nucleus. So they held the electrons closer. Okay, they held the electrons closer to the nucleus, therefore shorter, stronger yung bonds. All right, so let's erase that. So guys, you can also answer this on your own. You can also find other molecules sa Smith, no, na same din guys yung question. So I just gave you one example here. Okay, next, if this is about electronegativity and bond polarity. Ito guys ay introduction para dun sa last part ng chapter na to, which is about inductive and resonance effects. Maybe you have heard them number of times already, no, sa organic lecture ninyo. So let's just recall electronegativity guys and bond polarity. So ito yung may kinalaman guys yung electronegativity difference. So carbon bonds, example tayo. Ayan, carbon bonds guys, non-polar because they have the same electronegativity values. And you also know sa organic, no, even sa Gen Chem, carbon hydrogen guys, very small yung electronegativity difference nila. So kaya we also treat this as a non-polar bond. However, in this example, carbon bonded with oxygen, we know that oxygen is an electronegative atom. It's electron rich. Ayan, no, partially negative yung side ng oxygen, partially positive yung side ng carbon. So indeed, a carbon-oxygen bond is an example of a polar bond. Okay, so we are just recalling guys yung ibig sabihin ng non-polar at saka polar bonds. Same pa rin naman dito sa organic chem. Here guys, sa mga slides natin, especially sa books guys na gagamitin ninyo, you will find this color coding scheme, no? Itong color scheme na to para guys sa electron density. Yung warm colors, ayan, malapit sa red, no? Red, orange, yellow. Ibig sabihin yan, increasing electron density. So usually you find this side sa mga oxygen, halogens, yung mga atoms guys na electronegative. And then yung mga cooler colors, green, blue, they are for portions naman na decreasing ang electron density. An example here is an alkyl halide, no? Ito guys ay chloromethane. Wherein chlorine Of course, yung electronegative atom sa molecule, as you can see, partially negative, doon nakaturo yung partially negative na side. So you could see, guys, na nasa kanya yung warmer colors. O, diba? Sa electrostatic potential plot niya. And then, of course, sa side naman ng carbon hanggang sa hydrogen, green to blue to purple kasi yun yung cooler colors, meaning electron deficient or mababa yung electron density. So just so you know, guys, ganyan yung pattern sa mga books when they want to depict electronegativity and of course electron density. Now, let's talk about inductive effect. Since na-recall na natin yung meaning ng electronegativity and polarity. Inductive effect means the pool of electron density through a sigma bond caused by electronegativity differences of atoms. So ito guys, meron tayong example, 'di ba? So related pala ang inductive effects sa electronegativity. Again, the pool of electron density through sigma bonds. So we have here two examples guys ng organic compounds, ethanol and 2,2-trifluoroethanol. So guys, based on their pKa values, we can say that 2,2-trifluoroethanol is the stronger acid. Actually, mas malilinawan tayo guys if we will look at their conjugate bases para mas makita nyo guys yung meaning ng inductive effect. For the conjugate base of ethanol, which is CH3CH2O-, there is no additional electronegative atoms that stabilize the conjugate base. Okay, di ba negatively charged yung mga conjugate bases natin? Dito guys, walang factor or walang component na mag-stabilize sa negative charge ng CH3CH2O-. However guys, dito sa CF3CH2O-, we have fluorine atoms. CH3, ngayon CF3. The fluorine atoms withdraw electron density, thereby stabilizing the conjugate base. Nasa-stabilize na guys yung negative charge ng conjugate base. Diba? And this is what we call inductive effect. So, the ethanol here na may mga fluorine atoms, yung stronger acid as compared sa normal lang guys na ethanol. And you will see guys later sa next chapters natin, dun sa mga compounds na acidic, the presence of halogens. Okay, the presence of halogens will actually increase the acidity of that compound. Similar guys sa effect dito sa ethanol versus 2,2-trifluoroethanol. So we have used the reasoning, okay, about inductive effect to explain kung bakit siya stronger acid. There's another one. Ang tinatawag guys na resonance effect, for sure familiar kayo because you know what resonance structures are, di ba? So based on their pKa values, acetic acid is the stronger acid. Let's look at its conjugate base. Kanina nakita niyo na kasi ang conjugate base ng ethanol. If acetic acid donates its proton with a base, ito na guys ang kanyang conjugate base, which is acetate. Ayan. Actually, meron siyang dalawang resonance structures. O, diba? So, yung negative charge guys ng conjugate base na to ng acetate is delocalized on 2 oxygen atoms. So, we can say that this is a resonance stabilized conjugate base. Actually guys, maririnig nyo ng maraming beses sa review natin dito sa organic ang phrase na resonance stabilized. Okay? So ito ang ginamit naman natin na reasoning para i-explain why acetic acid is a stronger acid than ethanol. So guys, those are inductive and resonance effects. So gamitin natin yan to answer sample problem 4. This is fomalinic acid C. It is an inhibitor of bacterial fatty acid synthesis. Here's the question. Which hydrogen atom is most acidic? So guys, obviously, ito na yung answer natin. No? This is the most acidic hydrogen. So since kakatapos lang natin kanina ng resonance effect. Okay, the second question here, rank the labeled bonds in order of increasing bond strength. So similar guys sa isang problem natin kanina. So the labeled bonds are bond 1, 2, and 3, and all of them are single bonds. So we have to determine first yung orbitals, hybrid orbitals that were used to form these bonds. So ito guys, for bond 1, this is sp3 carbon sp, and then sp is p. Okay, so that's bond 2. Bond 3 naman guys, carbon sp2 and carbon sp3. So let's first write or identify yung bond na weakest Okay, pinaka-weak yung bond strength dito. So, ang pinaka-weak guys dito, isipin natin na sp3, sp, 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 sp2, sp3. Ito guys. So, bond 3 ang ating weakest. So, the bond there is the weakest yet the longest. Okay? Followed by, so let's use the symbol, followed by bond 1. And of course, guys, alam niyo na ang reason bakit bond 2 ang ating strongest bond, shortest bond here. It's because the orbitals forming the single bond or bond 2 is from carbon sp and carbon sp. So since natapos natin kanina guys, diba, yung percent S character. So this is the answer guys for the second question na ranking ng labeled bonds in order of increasing bond strength. So hopefully guys nakakabalik kayo sa organic chem language through our lessons and sample problems. Okay. So for the last part, guys, ng structure and properties, add ko lang pang part na to. Actually, you will also see this later sa chapter naman natin on alkenes. This is, guys, determining the types of bonds. Ibig sabihin ng type of bond, single, double, triple. Okay? So ito, guys, ang ating i-compute to determine the type of bonds. This is called the degree of unsaturation or also known as the index of hydrogen deficiency. The Greek letter, the symbol for this guys is rho. So I'm hoping na familiar kayo guys sa rho. Rho is equal to 2 plus 2c minus h plus n minus x all over 2. Ibig sabihin niyan guys, yung number ng atoms. Okay, so number of atoms. Ibig sabihin ng 2c, 2 times the number of carbons in a given molecular formula minus h, total number of hydrogens, plus n, total number of nitrogens, minus x, total number of halogens. You always get a whole number for this, 0, 1, 2, 3, etc. Now, these are the consequences, guys, na makakompute nyo na 0. And yun ang ibig sabihin. Kapag nakapag-compute kayo ng rho equal to 0, meaning all single bonds lang. You don't have a ring, you don't have a double bond, or of course, wala ka ring triple bond. But if you get rho equal to 1, ibig sabihin, guys, for the entire molecule, for the formula given, there's one double bond or one ring. Okay? Actually, guys, dapat na-gets na natin kanina yung ibig sabihin ng hydrogen deficiency. Kasi as you draw or as the multiple bonds increases, ibig sabihin nan guys, may double, triple ka, nababawasan yung hydrogen, di ba? Kaya tinawag siyang degree of unsaturation or index of hydrogen deficiency. Sa chapter guys ng alkenes, alkynes, aromatics, malalaman ulit natin na marirecall natin, ma-apply sa kanila yung term na unsaturated. Okay? Dito, yung term lang muna na hydrogen deficiency. Kasi nababawasan yung hydrogens as we form multiple bonds. When I say multiple, double or triple. And then rho is equal to 2. Ayan, ang dami niya guys ibig sabihin. Rho equal to 2 meaning pwede siyang dalawang ring, dalawang double bond, or tig-isa, one double bond or one ring. Rho is equal to 2 is also equal to 1 triple bond. Okay, so try natin guys to ha. Kasi magagamit nyo to guys sa mga problems na given yung molecular formula, tapos i-ask kayo, what would be the probable structure for this compound, or pwede rin na what possible functional groups could be present for this particular molecular formula. Okay, let's now answer sample problem number 5. Let's fill in the following table. Ayan. May molecular formula tayo guys sa first column. We will get rho and draw probable structures guys for each particular formula. So sige, drawing tayo. Magpapalit ako guys ng color. Green. Ayan. Ano kaya ang rho ng C6H14? So guys, let's compute the rho. Rho is equal to 2 plus 2C. So that will be 12 minus 14 divided by 2. So guys, ang rho ng C6H14 ay 0. So ibig sabihin yan, wala siyang double bond, walang ring, at syempre wala rin guys, triple bond. In fact, ang structure guys na applicable for C6H14 is the structure of N-hexane. 1, 2, 3, 4, 5, 6. So itong compound na to, ang formula niya, C6H14. Next, C6H12. So ang rho na guys, 2 plus 12 minus 12 all over 2. So guys, ang rho nito, 2 over 2 equal to 1. So guys, kapag 1, ibig sabihin yan, mababawasan yung hydrogens. Kaya nga ang tawag sa RAW, index of hydrogen deficiency or degree of unsaturation. So possibility guys, may double bond na isa or pwedeng isang ring. So yung double bond, gawin natin guys. So you can place a double bond sa terminal or pwede rin guys somewhere sa middle. So hindi naman tayo required na isulat lahat. Okay? Although later when we move on to the topic of isomers, you will see guys na mga constitutional isomers, yung karamihan dito. So you have to also enumerate kung ilan yung possible. So, hindi naman parating goal yon. Ang goal naman natin is to compare yung decreasing na number of hydrogens at yung effect sa structure and of course, nagko-compute tayo ng raw. So, isa pa guys na possible compound dito, of course, is your 6-membered ring. So, cyclohexane. O, diba? C6H12 yan. Ngayon, kapag sinabi sa instruction na draw all possible structure, syempre isipin nyo guys, cyclohexane lang ba ang pwede? Pwede rin naman siyang cyclopentane, ganyan. Pero may isang substituent, methyl. Pwede rin 4-membered ring, 2 substituent, 3-membered ring, 3 substituent. So, explore all possibilities ha guys. C6H10 is our next one. 2 plus 12 minus 10 over 2. Ang raw nito guys ay 2. So anong possible? Anong mga possibilities for compounds na ang formula ay C6H10? So ano ba ang combination na pwede guys sa raw equal to 2? Pwede ang dalawang double bonds. O try natin. Dalawang double bonds ma'am, pwedeng ganyan, pwede. You can also think of other way para makapag-draw ng dalawang double bonds. Pwede rin guys ang isang ring, isang double bond. Gawin natin isang ring, isang double bond. So, stick tayo sa 5-membered ring natin. Yan, double bond. Gets nyo guys ilagay. Tapos isang substituent. Diba? Rho is equal to 2. What else? Pwede rin 2 rings. Try nyo guys ha. At pwede rin guys, syempre, ang triple bond. So, let's say guys, yan. So, yan, triple bond. So, yan ang hexane. Terminal lang din drawing ko. Terminal alkyne. You can also draw, guys, an internal alkyne. So, hindi ko naman sinabi kanina na lahat ng structures, all isomers consider drawing nyo. Okay, there's no need for that. But if you can do it, guys, no problem. Para ma-practice rin kayo. We have here C6H8, guys, 2 plus 12 minus H over 2. So, this is 14 minus 8, 6 over 2, 3. Oh, ang dami. Ang dami na guys possible sa rho is equal to 3. Homework nyo na yun ha. Kayo na guys ang mag-ano nito ha. Kayo na ang mag-drawing. Ang dami. Kasi ang dami guys possible kapag rho is equal to 3. You can have 3 double bonds. Although hindi possible yung 3 rings, no? Because you only have 6 carbons. You can have 1 ring, 2 double bonds, 1 double bond, 2 rings. Explore possibilities na appropriate for the formula C6H8. And then we have the last one here, guys. 2 plus 12 minus 6 over 2. That's 14 minus 6, 8 over 2, 4. Lalo na yung 4. Lalo na yung rho is equal to 4, guys. Marami din siyang possibilities. Okay? Guys, isa dyan, drawing ko ha. Madami pa ibang possibility. Pero ito yung naiisip ko kasi agad. Yan. O, diba? So, this is benzene ring. C6H6, guys. Bawat carbon dyan, may tigi-tigisang hydrogen. So, you can see, guys, that as we decrease the number of hydrogens, unsaturation ay nagiging resulta. Diba? Kaya nga siya degree of unsaturation, index of hydrogen deficiency. So, calculating raw, determining raw, guys, will actually help you determine the structure of the compound. Whether may double bond ba siya, triple bond, or ring, it will help you. Okay, so kaya dapat marunong tayo gumamit ng raw, marunong mag-calculate ng raw. Alright, so yan guys, that's our chapter 2, structure and properties. Now, okay, we move on to chapter 3. Still guys, under pa rin to, or coverage pa rin to ng practice test 1. So we have here nomenclature. The topic is about naming of organic compounds. We will review IUPAC system of nomenclature. Of course, functional groups and compound classes. And ito yung special topic natin dito, guys, polycyclic compounds. Okay, so let's begin, guys. Recall muna. Since dito sa names ng alkanes, guys, nagmumula nanggagaling yung mga stem names ng mga compounds. So we all know this. Recite lang natin, no? Methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. So you will be using the following stems for all of the compounds na papangalanan guys natin using IUPAC system. Meth, eth, prop, but, pent, hex, hep, oct, non, dec. So lahat yun guys, magagamit natin. Okay? Sa last column nakalagay dito, number of constitutional isomers. Ibig sabihin guys, isomers na may differences lang sa attachment of atoms or sa bonding ng atoms. Meron tayong exercise para dyan mamaya. Now, before we recall the steps in naming guys, nasa manual nyo rin yon. Let's recall alkyl groups. Diba? Let's say methyl. O, ang methyl ay derived from methane. Nasaan yung methane natin? If we remove one of the hydrogens here, guys, ayan, it becomes a methyl group. Now, it becomes a substituent that can attach to a parent chain. Ayan. Ito naman, guys, propyl, isopropyl. O man, parang walang ethyl. Hindi ko na guys sinama yung ethyl dyan kasi for sure, alam niyo naman kung paano na-form yung ethyl. Ito siya, CH3, CH2, that will be attached to a parent chain. So now, here in our slide, we have propyl. So guys, of course, ang propyl galing sa propane. If we remove a primary hydrogen, ma-mitch ano po yung primary tsaka secondary. Later on guys, meron tayong portion para sa primary secondary, no? So I hope you're still familiar kasi sa alkane chapter pa guys, magkakaroon tayo ng portion ng primary, secondary, tertiary, quaternary. So without us defining yung terms na yon for chapter pa nga niya ay alkanes, I'm sure guys familiar kayo sa primary, no? So primary hydrogens guys, itong terminal natin C1 and C3, if we remove a primary hydrogen, one of the primary hydrogens, we end up with a propyl group. On the other hand, if you remove one of the secondary hydrogens of propane, you get an isopropyl group. Okay, so yun guys ang origin ng dalawang alkyl groups na yan. So one word lang guys ang isopropyl, also isobutyl, and later guys sa next slide meron tayong sec-butyl. Sec is for secondary, tert is for tertiary. So how do we form yung mga alkyl groups na yan? Ito guys. So we have here butane. If we remove one of the primary hydrogens of butane, of C1 and C4 in butane, guys, from C1 and C4 in butane, you arrive at a butyl group. On the other hand, if we remove one of the secondary hydrogens of butane from C2 and C3, you end up with a sec-butyl group kasi removal ng secondary hydrogen. Now, we have here isobutane. If we remove one of the primary hydrogens of isobutane, which is, of course, obviously, guys, a constitutional isomer of butane, you end up with an isobutyl group. Okay, isobutyl group, yung alkyl group, resulting from the removal of one of the primary hydrogens. And then, guys, kapag yung tertiary naman yung tinanggal, naturally, tert butyl group. Ayan, familiar kayo malamang, guys, sa tertiary or tert butyl group. Okay, so review lang to guys. Kahit na wala pa tayo sa primary, secondary, tertiary, for sure, alam na alam nyo pa rin yan. So let's have a quick recap. So we have isopropyl, sec-butyl, isobutyl, tert butyl. Ito pa guys, isopentyl, okay, aka isoamyl, neopentyl, tert pentyl. Okay, so this is how we form the alkyl groups. Now guys, let's proceed with the IUPAC system of nomenclature. Here guys, in your review manual, let me just guide you. The IUPAC system, the rules for IUPAC system is on page 4. Although guys, nasa manual na yan hindi natin babasahin isa-isa yan. We will just look into the basic parts or yung basic steps dun sa IUPAC system. PPS, diba? Parang letter lang. PS, di ba sa letter PS? Ito naman PPS, postscript. Okay, pero guys, dito sa naming, ang ibig sabihin guys ng PPS, ito kasi guys yung formula ng isang IUPAC name. So ang isang pangalan guys ay binubuo ng prefix, parent, suffix. Okay, pero guys, ang unang-una talagang kukunin natin or i-determine natin is yung parent. Okay, PPS. Kung alam niyo sa sulat yung PS at saka PPS, di ba? This can help you remember the formula of a name. Prefix, parent, suffix. Step 1. determine the parent hydrocarbon chain, which is the longest chain. Ayan. Actually, madaya. Naka-red na guys yung parent chain dito. Counting guys kung ilang carbons yan, that is 1, 2, 3, 4, 5, 6, 7, 8. So the parent hydrocarbon chain of this compound is octane. So check na yung step 1, alam mo na yung parent. Okay? And then guys, step 2, attach the suffix which is the parent functional group. Like kanina do sa unang compound natin, so that will just be ane kasi octane. However guys, dito, yan. Dito guys, ano na, meron tayong functional group na OH. So your suffix here will be ol because of the alcohol or hydroxy functional group. So ma'am, pwede bang balikan natin yung step 1 niya? Ano yung magiging parent niya? Pwede guys. So count natin na. So this will be our carbon 1, carbon 2, carbon 3, 4, 5, 6, 7, 8. O ma'am, ba't yan po yung ginamit nyo na path? Pwede bang iba? Kasi guys, ang hinahanap natin sa step 1, longest carbon chain. And since we have here an ol, we have a hydroxy group, we should include it sa parent chain. And then the rest guys na hindi na isama, they become the next part, okay? They will be part of our prefix. So ma'am, ano po magiging name niya after knowing step 1 and steps 1 and 2? So syempre guys, yung magiging parent name nito, octanol. Kasi 8 carbon chain, yun ang kanyang longest hydrocarbon chain, yun ang kanyang parent, at tapos meron siyang hydroxy group, so it's an alcohol, octanol. So, yung octa, 'di ba, galing doon guys sa stem ng octane, tapos yung ol, suffix for alcohols. Okay, next, step 3 is to attach the prefixes. Excuse me. These are the side chains or substituents. So guys, for our first compound kanina, 'di ba, octane yan. So lagyan na guys natin ng substituents niya. At carbon 4, we find an ethyl group. And then at carbon 5, we find a methyl group. So its full name is 4-ethyl, 5-methyl octane. O baka magtaka kayo, ma'am, pwede bang pagbalik na rin yung 4 tsaka 5, yung ethyl-methyl? Guys, meron tayong rule na kailangan alphabetically arranged. Okay, alphabetically arranged guys dapat yung substituents natin. So remember that. Okay, next guys, our second compound. So we already know na octanol siya. Carbon 3, yung OH. So it will be 3-octanol later. Ma'am, sa books, nakikita ko pwede rin yung octan 3-ol. Pwede rin yun guys. At carbon 4, we find an ethyl group. At carbon 5, we find a methyl group. So the name is 4-ethyl, 5-methyl, 3-octanol, or 4-ethyl, 5-methyl, octan 3-ol. Both are correct. Alright? O diba guys, madali lang. So kahit i-go over nyo pa guys yung rules dyan, na-apply na rin natin siya dito. Though, very simple lang kasi yung mga examples natin here. Okay? So now, let's give names to more alkanes. Sample problem number 6 is to give the IUPAC names of the following alkanes. So ayan guys, magka-count lang kayo. So 1, 2, 3, 4, 5. So parent name, that's step 1, di ba? Pentane. And then we find methyls at carbons 2 and 3. The complete name, 2,3-dimethylpentane. Okay? So again guys alphabetically arranged. Tapos baka isipin nyo, Mitch, ba't hindi tayo nag-start ng counting ng carbon sa left side para siya ay maging 3, 4? Guys, ang rule kasi dapat gagamitin ninyo yung lowest possible numbers for the substituents. Kasi, syempre, paano kung iba yung counting mo, iba yung sa akin? Then, maybe, magkaiba tayo ng compound na pinare-refer, pero isa lang pala. So, universally, guys, yung mga rules, naisip na to, guys, na formulate na to, para kahit magkaiba, for example, tayo ng language, let's say, no, but we will boil down to the IUPAC language, then we will be referring to the same compound. Okay? Kahit na iba pa yung isipin mong counting, marirealize mo, may IUPAC system nga pala, wherein the substituents must be alphabetically arranged, the substituents must have locants or numbers na lowest possible yung set niya dun sa compound. Always remember that. Okay? Next, So we have this 1, 2, 3, 4, 5, 6, 7, 8. O, diba? Octane. And then meron tayong dalawang substituent, ethyl and methyl. Parang ito yung kanina. Ito yung kanina dun sa example natin. Na guys, 4-ethyl, 5-methyl octane. Okay, next. Ayan, mas malaki guys. So let's count guys. So this is 1, 2, 3, 4, 5, 6, 7, 8. Pasensya na. Lumilipad yung sulat ko. So at carbon 3, we have a methyl group. Carbon 4, we have methyl and ethyl. So dapat guys mauna yung ethyl group. So the correct name for this compound is 4-ethyl 3,4-dimethyl octane. So ma'am, bakit may di? Kasi guys, dalawa. So we use the Greek prefix di to indicate there are 2 methyls. Kung 3, tri. Kung 4, tetra. Okay, so we use those prefixes but we don't include them guys sa alphabetization. Okay, E pa rin at saka M. So E comes before M. Okay, last guys. So guys, let's count yung kanyang number of carbons sa parent chain. So this is 1, 2, 3, 4, 5, 6, 7. So this is heptane. We have methyls of carbon 2, 3, and 5. So 2, 3, 5, trimethyl. Okay, meron pa pala tayong propyl, guys. 4-propyl heptane. Ayan. So sabi nga dito, pick the long chain with more substituents. Kasi baka meron pa kayong ibang makitang way to count this. However, you pick the chain with more substituents. So yung mga rules na sinabi natin kanina, alphabetize the substituents, do not include the prefixes. Make sure your locants, your substituents have the lowest possible numbers and pick the parent chain with more substituents. So lahat naman guys yan, nasa manuals natin. Okay? Kasi magko-consume ng time natin here sa video if I will read pa, di ba, one by one yung mga rules. You all know them, familiar tayo. So I gave you examples. Okay? So ayan guys, ang sample problem number 6. Now, also guys, familiar din dapat tayo sa different types of functional groups. So define muna guys natin. Functional groups could be an atom or group of atoms that are responsible for the characteristic chemical behavior of organic compounds. They are the structural features that makes it possible to classify compounds into different compound classes. That's why kanina 'di ba meron tayong sinabi ko kanina na term na alkanes, alkenes, alkynes, alcohols. So those are compound classes. So ito guys, you will see this in your manual. Ayan. So guys, here's our list of the different compound classes. So we have hydrocarbons muna guys, alkanes, alkenes, alkynes, arenes. And then we have the group of alcohols and phenols. Isama natin guys na rin yung ethers. Kasi guys, usually isang chapter yung mga yan, alcohols, phenols, and ethers. Then we have the group, okay, itong dalawang compounds na to, they contain the functional group carbonyl. Then, ang tawag nito sa kanila guys, together, carbonyl compounds, aldehydes and ketones. Then we have the compound class of carboxylic acids and derivatives. Kasama dyan na anhydride, ester, amide, acyl halide. Okay? And guys, the rest here, we have alkyl halides, we have amines, thiols, nitriles. So we can group them guys according kung sila ba ay hydrocarbon, oxygen-containing, carbonyl-containing, halogen-containing, nitrogen-containing, sulfur-containing, etc. Okay, so actually guys, hindi pa to kompleto. Meron pang ibang groups and meron pang ibang functional groups, meron pang ibang compound classes na makikita nyo rin naman guys sa books at saka sa end, towards the end of our review. And for sure, you're gonna see them as well sa biochem. So for now guys, ito muna, recall lang muna natin yung mga basic groups or mga basic na compound classes. Okay? Actually, another thing pa guys na related sa functional group ay ang IMFA or recall lang ha, from Gen Chem, di ba familiar naman na kayo guys sa intermolecular forces of attraction. So guys, let's just recall, van der Waals, the weakest among them, is exhibited by all molecules. So take note, default to guys ng mga molecules sa van der Waals. However, in Gen Chem, we call this London dispersion forces. Next guys is our dipole-dipole forces or dipole-dipole interactions wherein exhibited to guys na molecules with net dipole. So we have here an aldehyde and an alcohol. We have hydrogen bonding, a strong type of IMFA, wherein, recall, this is present in molecules with, or this is exhibited, sorry, by molecules with OH bond and H or HF bond. So ang example dito ay alcohol. Ion-ion dipole, guys, very strong type of IMFA, of course, ionic compound. So recall lang guys, kasi gagamitin natin guys yung concept ng IMFA if we want to predict patterns in solubilities, patterns in boiling points, melting points, etc. So very important guys na ma-recall ninyo yung relationship ng functional group kasi ano yung connectivity ng atoms, di ba? And with IMFA. Alright, so ayan, sample problem tayo guys. Identify the following groups, or sorry, identify the functional groups in the following compounds. So our first compound here, the artificial sweetener, aspartame. So ayan guys ha. So we will now identify. So let's choose, ano na lang guys, red. Okay. Kaso may red na pala dyan. Sige. You know, let's just go with green. Okay. Guys, ito, madali lang. Circle ko ha. This group is carboxylic acid or yung compound class niya, carboxylic acid. So usually napapagpapalit natin yung dalawa, no? Yung functional group tsaka compound class. They're related naman with one another. This one, guys, is an ester. This one is an amide, amine, at syempre guys, ang ating phenyl group under aromatic or arene para mas maikli. So we have 1, 2, 3, 4, 5. Ayan, meron tayong 5 groups guys na na-identify sa aspartame. Again, carboxylic acid. We have the ester group, amide, amine, and phenyl group. Pwedeng tawagin nyo na rin arene, okay? Or aromatic ring. Okay? So guys, madali lang siya, no? Next, let's identify the groups naman in this compound, cephalosporanic acid. Okay, guys? First, we have again the ester. Okay, kamukha nung kanina. We also have here the carboxylic acid. We also have here the amide, though nasa cyclic ring naman siya. Also, the amine, parang similar sa kanina, no, yung groups. However, guys, wala naman kanina dong double bond, no? Walang alkene double bond doon. Pero may aromatic ring kanina. And ito, ano kaya yan, ma'am? Thiol po ba yan? Hindi, guys. Ang thiol ay SH kasi dapat kamukha siya ng OH. However, ito guys, ang tawag guys dito ay sulfide. Okay, ma'am, pwede rin po ba siyang derivative ng ether? Pwede guys. You can also call this the thioether. Okay, just in case hindi kayo familiar sa isang sulfur-containing group. So, SH thiol, ito S, okay, connected to our groups sulfide, or we can also call it a thioether. All right, so ito naman guys, our next problem. So we have 3 compounds here. Label the hydrophobic and hydrophilic portions of each molecule. So guys, kapag carbon-hydrogen lang yung network ng bonds, hydrophobic yon. Okay, so carbon-hydrogen, carbon-carbon din syempre. So ito guys, itong halos lahat ng to, yan, halos lahat yan. Halos lahat guys, hydrophobic. Okay, o gawin ko namang kulay blue guys, yung para sa hydrophilic. Syempre, yung mga may polar portions. Diba? Yung mga electronegative. Although ito sure tayo, OH bond yan eh. Ito guys, magkakaroon lang ng dipole-dipole interaction yung oxygen with water molecules. Syempre ito guys. O, diba? Kasi meron tayong COOH. Ito, dipole-dipole interaction, hydrogen bonds. This will form hydrogen bonds with water. So, if you will compare guys, kapag mas malaki ang hydrophobic portion, then the molecule becomes water insoluble. However, if the molecule has enough hydrophilic portion, then it could be water soluble. Okay, yun nga lang, merong marginally soluble, merong partially soluble. So it depends din guys talaga sa overall na polarity ng structure. Okay, so that's it for our sample problem 7 and 8. Now, let's move on naman guys to polyfunctional compounds. Ito guys, yung mga compounds na there will be 2 or more different functional groups, kaya nga siya polyfunctional. So, kailangan nyo guys isipin, if you have several groups in a single compound, which becomes the substituents and which becomes the parent. So, meron tayong list guys ng groups Ito yung hierarchy nila actually. So you also have this, guys, in your manual. So on top of the list is carboxylic acid. If it's the parent, guys, sa isang compound, no, lahat ng groups nandyan, carboxylic acid yung dapat maging parent. A suffix name yung gagamitin natin, which is oic acid, followed by ester, amide, nitrile, aldehyde, ketone, alcohol, for sure, familiar kayo sa hydroxy. Hydroxy kung substituent. Kung suffix naman, ibig sabihin alcohol, yung magiging parent ng compound ol. Then we have amine, alkene, alkyne, alkane. Guys, napansin niyo ba yung ether tsaka alkyl halide? Naka-blank yung suffix name because they are usually used as substituent. So silang dalawa kasi, guys, yung may pinakamababa na pwesto sa hierarchy na to. So you usually find compounds, polyfunctional compounds, kung may ether na group, then we use the substituents alkoxy, meaning methoxy, ethoxy, propoxy, ganyan. Alkyl halide, halo. So chloro, bromo, fluoro, iodo. Diba? So those are the prefix names nila as substituents. Okay? O guys, para mas maging malinaw to, no? Para ma-practice natin, guys, yung naming, meron tayong sample problem. However, let me just give you this, no? Kasi guys, sa lahat naman ng chapters natin, sa lahat ng compound class na dadaanan natin, lagi tayong may subtopic na naming. So don't worry kasi mapapractice natin, guys, yung naming, yung nomenclature skills ninyo every time meron tayong bagong compound class. Okay, so guys, let's answer sample problem number 9. So let's give the IUPAC names of the following polyfunctional compounds. Ayan, may number na kaagad. So guys, ang parent nito ay 4 carbons. So that will be butane. Tapos aalamin natin ano, guys, yung magiging suffix niya. So we have 3 groups here. We have amino group at carbon 3, hydroxy group at carbon 2, and the aldehyde group at carbon 1. So kahit i-check nyo pa, guys, yung manual ninyo, no, while watching, you will find that aldehyde yung may highest priority among the 3. So it means that this compound will become an al. Al yung suffix niya. Ma'am, di ba butane? So butanal, guys, yung magiging parent name nito. And then we have the following substituents. Arrange them alphabetically. 3 amino, 2 hydroxy, butanal. So that is the name of this compound. Okay, very easy. Okay, next, guys. Ayan. So ano kaya magiging parent name ito, guys? Diba yun ang ating step 1? So 1, 2, 3, 4, 5, 6 coming from hexane, yung magiging parent name niya, guys. Then we have 2 groups here. Ketone. Ito, guys, ang ketone. Ito naman ang ating ester. And if you check yung list natin kanina, guys, higher ang priority, guys, ng ester. So this will have the suffix O-weight. O diba, 6. So, hexanoate. Okay. Ma'am, paano po yung substituent at carbon 4? Then that ketone group will be assigned as a prefix na siya. So, it becomes 4-oxohexanoate. But wait, guys. Ma'am Mitch, hindi ko kasi maalala yung pag-name ng ester. Bakit po may methyl? Ito kasi siya, guys. Kasi ang mga ester, instead of having OH, meron siyang OR. So we say first, or we write first the alkyl group, and then ito na nga, hexanoate. So kung walang ketone dyan, it will be methyl hexanoate. Kaso meron tayong 4-oxo. So kaya nakasingit pa yung 4-oxo-hexanoate. So sabi nga dito, it's a derivative of an ester. Okay, next compound. There. So benzene compound naman to, guys. May benzene ring tayo. Aromatic compound to. We have 2 groups. We have the cyano group. Okay, ang CN, guys, as a prefix, cyano. And then, eto naman, guys, carboxylic acid yan, di ba? Oh, now you will remember, ma'am, di ba may common name yung mga aromatic compounds? Exactly. If you remember that lesson, then malalaman mo yung tamang parent dito. The parent name of this compound, guys, is benzoic acid. Kasi itong benzene ring with COOH, common name niya, or yung accepted name niya, guys, ay benzoic acid. By the way, there are common names kasi, guys, na accepted din sa IUPAC. So ito, benzoic acid to, guys. However, meron pa tayong cyano group. O, diba? So anong relationship nila? Pwede bang number na lang? Pwede, 1, 2. However, guys, pwede rin tayong gumamit ng orthometa para for disubstituted benzenes. Although wala pa tayo doon, polyfunctional compound to kasi guys. So it's part of our naming exercise. Don't worry, we will have the same lesson again pag tayo nagpunta guys sa aromatic compound. So this COOH, as I've said, siya yung may higher priority between it and cyano. Okay, so this is orthocyanobenzoic acid. So pwede ring 1, 2, pwedeng ortho, will reach to that. Kapag nasa chapter na guys tayo ng benzene and aromatic compounds. Okay, so that's it guys. Madali lang mag-name ng polyfunctional compounds as long as you remember which will have higher priority. Okay, so kailangan nyo lang yan guys review. Don't worry, lahat naman ng groups madadaan natin ang naming system nila. Okay, so guys, last part na to. Ito na yung last part talaga ng PT1. This is about polycyclic compounds. So ayan, sa manual guys, tingnan ko lang sa manual ha. So in your manual, it will be found on page 5. Okay, and isang buong page yan guys na puro about polycyclic compounds. So we have 3 types. Type 1 is what we call spirocyclic, wherein 2 rings share 1 single atom. Ayan guys, so 1, 1, 1. O diba lahat sila may single atom. So we attach the prefix spiro XY, saka square bracket, where X and Y are the number of carbon atoms in the smaller and bigger rings respectively. Ako guys, tinatandaan ko dyan, spiro, smaller. Okay, di ba? Para silang S, S, S. Okay? So let's give the names, guys, of the following. So walang problema sa una, no? Kasi pareho namang 3-membered ring ng dalawang rings niya. Ilang carbons meron sa kada ring? So we have 1, 2, 1, 2. So the name of this compound, of course, will be spiro 2, 2. Ano pong ano niyan? Parent niyan. So count the number of carbon atoms. So parent pa rin guys yung tawag natin dito. So this is what? 4 plus 1, 5. So ang name na guys, spiro 2,2 pentane. Take a look at the way it was written. So walang spaces guys ha. Spiro 2.2 pentane. Okay, next. So smaller muna, spiro, smaller, SS, para di kayo malito. So 1, 2, 3. So there are 3 carbons sa smaller ring. 1, 2, 3, 4. There are 4 carbons naman sa bigger ring. So 3.4. Mamit ano pong parent niyan. So it has 8 carbons. Ito guys ay spiro 3.4 octane. Okay? Next. So smaller ring guys, 1, 2, 3, 4. Bigger ring, 1, 2, 3, 4, 5. This is spiro 4, 5 decane. Next guys, ayan, pareho lang sila. No? So this is spiro 5, 5 undecane kasi 11 carbons yung total niya. So guys, madali lang ang pagnaname ng spirocyclic compounds. Don't worry, pag may substituent, ganun pa rin. You follow the same set of rules na ginawa natin kanina. You just attach the substituents, the substituents as prefixes for these parent names. Okay? Next guys, ayan. So kung napansin nyo, yung kanina, spiro, they share 1 atom. Ito naman guys, they share 1 bond. We call them fused bicyclic. So number 2 and number 3 actually are group of polycyclic compounds na bicyclic. So ito guys, 2 rings share 2 common atoms in 1 common bond. Here, we attach the prefix bicyclo x.y.0. Added to the root name where x and y indicate the number of carbon atoms in the rings. 0 indicates that the bridge head atoms are directly connected. So, kaya 0, kasi connected sila guys. Hence, the 2 rings share 1 common side. So guys, let's give the name of the following fused bicyclic compounds. Let's have the first one. So meron siya isang carbon dyan, isa dito. And then of course, .0 kasi they share 1 common bond or 1 common side. And total number of carbons naman na guys, 1, 2, 3, 4. So this is butane, diba? So this is bicyclo. Ang XY niya ay 1, 1, 0, butane. Okay, next. So wala naging problem dun sa unang compound, kung napansin nyo, kasi same lang yung number of carbon sa dalawang sides niya, dalawang rings niya. On the other hand, guys, yung mga sumunod, okay, ito, well, yung nasa baba niya, hindi din problem yung kung ano mauuna. But this two at the right side, there is a smaller and bigger ring. take note guys, hindi ito spiro. Nag-a-apply lang yung spiro, smaller, SS, dun sa kanina. Okay, yung technique na SS, spiro, start ka sa smaller ring. Dito guys, sa bicyclic, okay, pag bicyclic, you start at the bigger ring or bigger side. So, BB, di ba? SS, BB. So, ito naman guys, ilan ng rings, ilan ng rings, ilan ng carbons dito. So, we have 1, 2, 3. So, 3 yung mas malaking ring and then 1, 2, dalawang carbons naman sa mas maliit na ring. Ang total guys sa number of carbons nito ay 7. So, the name will be bicyclo 3.2.0 heptane. Ito naman, both rings have 3 carbons each. 1, 2, 3. Ang total number of carbons na magiging parent name niya guys ay galing sa, ano ba to? 6 plus 2, 8. So, octane. So, this will be bicyclo 330 octane. And finally, for our last example here, ang bigger ring natin 1, 2, 3, 4. Smaller ring natin 1, 2, 3. So together guys, ang parent naman nito ay 9. So this is nonane. Bicyclo 430 nonane. Di ba? Ang dali lang guys. So madali lang mag-name ng mga polycyclic compounds. Ma'am, paano yung sa PT may mga substituent? Just follow the rules in IUPAC system. Ganun pa rin naman. Ito guys, nire-recall lang natin paano yung counting, 'di ba, dito sa mga polycyclic compounds. And this is also bicyclic, you see guys, but they now share, 'di ba? Meron na nga yung bridgehead. Okay, meron na tayong bridgehead atoms na connected ng, basahin ko na lang, okay? Bridge bicyclic, 2 rings share 3 or more atoms, separating 2 bridgehead atoms by a bridge containing at least 1 atom. So, ayan guys, yung mga bridge ito. Bridge, 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 ito dalawa. Okay, so hindi na siya .0, hindi. XYZ na siya. It is added to the root name, bicyclo XYZ is added to the root name, where X and Y, again, indicate the number of carbon atoms in the ring. Again, guys, dahil bicyclic pa rin to, no? We start counting sa bigger ring. And then Z indicates the number of bridgehead atoms. Ayan. So, isa lang yung compound dito na may dalawang bridgehead atoms. So, let's count, guys. So, ito ay may isang carbon dyan. Ang name niya, bicyclo 111 pentane. Ito naman, guys, dalawa. No, diba? Tapos may isa doon. So, 221. The name is bicyclo 221 heptane. Ito naman, guys, ay meron siyang isa, dalawa, tatlo. Dalawa dyan. So, that's bicyclo 321 octane. And finally, guys, ang ating last example here, 222 lahat. O, diba? So, this is bicyclo 222 octane. So, guys, practice lang kayo. Pag nakakita kayo ng mga ganitong compounds, polycyclic, i-practice nyo lang yung counting. Again, spiro, you start at the smaller ring. Bicyclo, you start at the bigger ring. Alright? So, yan na guys ang ating last slide before you answer PT1. Again, you can rewatch again this video, this crash course video, bago kayo mag-answer ng PT1. You can read again the manual. You can visit our references, yung mga e-books natin guys, para super ready talaga kayo in answering this practice test. And guys, syempre, tulad sa ibang practice tests, ganun ulit ang gagawin nyo na routine. So read and then rewatch if you want before you answer the practice test. And then of course, do not forget guys to submit your practice tests, okay, so that malalaman natin yung scores ninyo and we can give you the correct suggestion, the correct advice for each subject and for also each topic. Okay, so guys I'll see you again in the next crash course video para naman sa PT2. Bye!